Hi, this is Miss Wiles, and in this question, there are a couple of things that are being worked on here. If you've already read the question, you know that you've got these three rectangles, and you're going to need to know what the area of the three rectangles is. Now, so of course, you already should realize that, okay, one of the things that I'm going to need to know to do this problem is how do I find the area of a rectangle? So you need to recall that the area of a rectangle is equal to its length times its width. And every rectangle has a length and a width. And that's the same case here with these three rectangles. But it's algebra. So, of course, instead of using those nice little numbers that we can use, we are using algebraic expressions. And we have three rectangles, so it's often helpful to make a little sketch. So we have a sketch of three rectangles. And then we go sentence by sentence and reread and label some things of what this is telling us. This one tells us that the length and width of one rectangle are x and x plus 1 units respectively. Now the units word just means that we don't know if we're measuring in inches or centimeters or meters or miles or feet or whatever, and it doesn't matter for this problem. The word respectively means that if I put it in order that the length and the width are x and x plus 1 respectively, then that means that the order that you see the first words are the same order that the next expressions or something go in. So the length and width are x and x plus 1 respectively. Now, you would expect that the length would probably be x plus 1 because we oftentimes think that the length has to be longer than the width, but it really doesn't. So I could label it like this, or I could label it like this. It doesn't matter, we're going to get the same answer because it's still a rectangle. The next sentence says that the length of a second rectangle is x plus 2 and x plus 3 units respectively. So the second rectangle, this side is x plus 2 and this side is x plus 3. And the third rectangle has a length that is 3 times the length of the first rectangle, and it has the same width as the second rectangle. So you have to go back and analyze, okay, if the length of the third rectangle is 3 times the length of the first rectangle, then the length of the first rectangle was x. And so the third rectangle has a length that is 3x. The width of the third rectangle is the same width as the second rectangle. So when you go back to the second rectangle, it had a length and a width of x plus 2 and x plus 3 respectively. And so the width of the third rectangle is the same as the width of the second rectangle, making it x plus 3. Let's pause here so that if you're watching the video, you can think about how we got these measurements for these rectangles. And if you're in class, you can ask questions that I'll come back. And if there's something I need to add to the video, I will before we go on. So now we have to look at what our end goal is. Our end goal is to find the combined area of the three rectangles. So we have to find the area of the first rectangle. We have to add the area of the second rectangle, and we have to add the area of the third rectangle. And you may wonder why I put those there, because you'll see that kind of thing as subscript, just kind of, it identifies where that's coming from, and a capital A almost always means area. So how do we find area? Well, if we had a rectangle that had a width of 3 and a length of 4, we would multiply the 3 times 4 to find that area being 12. And another thing I want to talk about is this square units. The only reason that there's a unit square, that square has nothing to do with the numerical part of that value. It's that we're multiplying units by units, and so we have units squared. That would be like inches squared or feet squared or something like that. A lot of times I see students think that that exponent needs to go with the number, but it doesn't. It's talking about we're multiplying inches times inches. And you'll see that in volume also. So now let's look at once we've got it set up, let's look at the algebra that we have to do. In rectangle number 1, our area is equal to the length times the width. So we have to do x times x plus 1. Well, you should recognize that as the distributive property. So x times x plus 1, if we do x times x, we get x squared, and x times 1 is x. That's as far as we can go with that. We can't combine those because they're not like terms. They're different. We have an x squared and we have an x. For the second rectangle, area still equals length times width, but now the problem's even more difficult. We have area equals x plus 2 times x plus 3. Well, that one changed quite a bit. So we have to do our double distributive or our FOIL or some method to do that. And because that takes a little bit more room, I'm going to move it over here and do some work. So we do x and x plus 2, and we multiply both of those by x plus 3. You're already thinking, and that's too much. But if you understand the process that you're going through, it really doesn't take too long. It just takes longer to talk about it. So we use the double distributive. We do x times x is x squared, and x times 3 is 3x. For the second part of the double distributive, we have 2 times x, which is 2x, and 2 times 3, which is 6. And remember, you're not even able to use a calculator here. So yes, you need to know how to do a little bit of multiplication and some addition. So now we need to combine the like terms on this one to simplify the second area. And we have x squared, and we have 3x plus 2x. That gives us 5x. And then we have the plus 6 on the end that cannot be combined with anything else. Now let's back up a little bit and say where we got this x plus 3 and this x plus 2. Well, this x and this 2 comes from x plus 2, which was the length of that rectangle, and the x plus 3 comes from the width of that rectangle. So we're still doing length times width. This is our length, this is our width, and this transforms to do the work. We use our double distributive property. And we find that the area for the second rectangle is x squared plus 5x plus 6. The third rectangle, if we go back up and look at its length and width, whoa, I'm moving all over the place, like Blair Witch Project. Okay, we got 3x and we've got x plus 3. So we need to multiply those two. 3x times x plus 3. That's a single distributive property, which by now we should have practiced it enough to be able to do this. We have 3x times x for 3x squared, and 3x times 3 for 9x. What we have to remember, what we said in the beginning, is that we have to combine all of these areas. So we have this x squared plus x, and this x squared plus 5x plus 6, and this 3x squared plus 9x, that all have to be combined. And so since it's really nice to organize things so that they are in the same, so that your like terms are together, write the first one, or keep the second one here because it's the longest one. And then arrange the other two in their like terms. The first one comes down here, and it's x squared plus x. The third one comes over here, and it's 3x squared plus 9x. And when we combine all of these for our great big rectangle, all three of these rectangles together, we find that the area is 1x squared plus 1x squared plus 3x squared for how many x squareds? We've got 5x squareds here now. How many x's do we have? We have 5x and 1x and 9x for a total of how many x's? 9 and 1 and 5. 9 and 1 and 5. 15. And that's 6. It's there on the end. And this is our final answer because nothing else can be combined. Nothing else can be combined. You can only combine x squares with x squares, x's with x's, and numbers with numbers. So if you keep it all very organized and lined up, you won't leave anything out, and you will see that your answer is not listed there. Because again, Miss Wiles is terrible. Let's change this one. We'll make this one right. 15 and 6. So we'll say our answer is B. Again, it's not going to hurt you on your test. Your test, the right answer is going to be there. Your answer is 15 or 5x squared plus 15x plus 6. But let me also say that if something happened on a test and the answer that you're getting is not there, pick the thing that's closest to it. After you go back and look and make sure that you did every single thing right. And that's all I have to say about that.